Welcome fellow learners. In this video, we will demonstrate how we can leverage latest AI frameworks and AI models to automate the process of filling out job application forms using a predefined CV or resume. To achieve this, we will create an AI web agent using LaVague. LaVague is an open source large action framework which can be utilized to develop web agents. Additionally, we will utilize Microsoft's Phi-3 vision model for OCR tasks like converting your resume or CV into text format. So let's first outline the objective we will set for our web agent and visualize what our final output will look like. We will be using a template CV. In this CV, if you see a person's name and his contact information like contact email, contact phone number, Twitter account, and all those things are written. A person's work experience is written. Person's different companies through which he has worked is also written in this resume. Person's skills, education, and those things are written. So these informations we need to fill out in our job application form. So this is the job application web page that we are going to fill out. So what our AI web agent will do, our AI web agent will firstly fill out the empty spaces in job application form. This is the web page, like full name, email address, phone number, and skills will be automatically written by our AI web agent. Once those empty basically fields are being written, our AI web agent will automatically click on the submit button, and we will get our final response. And this input full name, email address, phone number, and skills will be submitted directly without any manual intervention. So this is the whole use case that we are going to implement in this video. So let's see what are the different steps that we are going to follow in this video tutorial. So in this first step, we are going to import Phi-3 vision model and corresponding processor. We will be importing this Phi-3 vision model directly from Hugging Face. So we will be utilizing this Phi-3 vision model to next extract the text from this resume or CV. So we will extract like name, email, phone number, skills, his work experience, and all those things. Once we are having this text data, we are going to import LaVague framework. So we will also be customizing this LaVague framework as per our need. So once we have done customization, we will finally run our this web agent. So this web agent will be created by this LaVague directly, and we will pass the extracted text data from the Phi-3 vision model to it, and our basic objective to it. So once we have passed all those input to this web agent, we will run this web agent and it will automatically fill out the job application web page and submit it for us. Now you might be wondering how this AI web agent works. For that, let's first understand LaVague's architecture and workflow. So you can see a flow diagram in your screen. So let's first understand the different terms written in this flow diagram. The first term is objective. Objective is nothing but a global goal that user wants this AI web agent to achieve. So in our case, this goal would be to fill out this job application web page by utilizing the information provided in the resume. The second term is instruction. Instructions are basically the smaller steps that are needed to move towards the finally achieving the our final objective. So the smallest step would be to click on that submit button. The three other terms are like word model, action engine, and this driver. So the word model is basically it is used to analyze the user's objective and the current state of the web page, and then this word model will generate the instructions that will be passed to this action engine. So the instruction would be like we need to fill out the different name, email, and those things in the current web page, that is the job application web page, and those instructions would be passed to this action engine, and the work of the action engine to basically convert that instructions into the code. So code would be like the Python code or something. And once that code has been generated, that code will be passed to this driver. This driver could be like a Selenium driver, and that Selenium driver would basically run that code into our web page, and like let's say for an example, fill out all the information that are required in that job application web page. Once that has been done, another part that is being done by this driver is it will take the screenshot of the current state of the web page and pass that to our word model as a perception. And this loop will continue until uh, our final this AI web agent finds out like we can now stop. Like when it hits the submit button, it will understand now we can stop as our task has been completed. So this is the whole LaVague's architecture and workflow. Like first we will pass our goal objective, basically the you can say global goal, and then that objective will pass to the word model. Word model with the help of the objective and the current state of the web page that has been passed to the driver, it will take these two and generate some instructions. Those instructions will be passed to the action engine, and action engine will basically convert that instruction into the code, and then that code again passed to the driver. That driver will basically run that code and basically do the steps that are required to fill out the information in the web page and then clicking on the submit button, and then finally this web agent will finish its work. So this is the complete architecture that this LaVague follows. So few of the things like we will be using in this whole model is like we will be using multi-modal language models. We will be using simple language model to follow the text, basically generate the text. We will be using multimodal to basically take this screenshot and then find out what are the different steps that it needs to take next. And we will be also using embeddings. Those embeddings will be utilized to convert the information. Like sometimes it might need to take the HTML of the web page and find the different things that are written in those web page. So in that case, embeddings will be required to convert those HTML pages into vector database, and then finding out the most suitable current instruction required for to pass to the action engine through the word model. So this is the complete architecture. For these language model part, we are going to utilize Google Gemini API, and we will be using this Gemini API for free, as there is some limit to this Gemini API. But for this instruction purpose or learning purpose, we can use Google API for free completely. So, what was the thought process behind building this whole LaVague architecture? So, a lot of elements of this LaVague architecture are being inspired by Jan LeCun's research paper. So, I will be sharing that research paper link in the descriptions. But the paper proposes an architecture for AI that consists of multiple modules, each responsible for different functions such as perception, word modeling, memory, and action generation. These modules work together to enable the AI to perceive its environment, react to it, reason about it, plan actions, and execute them. Much like the human brain leverages and combines different cognitive processes. So now you must have got good understanding of how this LaVague's AI web agent works and what is its architecture looks like. And you have also got a gist of what are the different steps that we are going to follow to implement this whole complete pipeline into code. So let's start implementing this LaVague's AI web agent. We will be utilizing Google Colab to implement this AI web agent. So let's first connect to a GPU server. If you haven't selected this GPU runtime, you can click on this runtime and then change runtime type. And then you can select this T4 GPU and click on save. Once you have done that, you can click on this connect button and you will be connected to a GPU server. This Google Colab usually provides 15 GB of GPU, free GPU. So you can check the available resource from this view resources, and you can see that we are having around 15 GB of GPU. Once we have done that, let's first install all the required libraries. So we will first install the libraries required for this LaVague's AI web agent. So we will be installing this LaVague, and we will be utilizing these LLM models through Llama Index. For that purpose, we will be installing these Llama Index libraries like Llama Index Multimodal, Llama Index Embedding, and also like Llama Index LLMs Gemini. So as we are using a Gemini, we are not using any paid APIs for the LLM part. We will be using only Gemini's you can say free APIs. So there will be some constant till what or till this number of requests we can do per minute for this Gemini APIs. But we can do this for our experimentation and for the learning purpose. So once it has been done, we can next install the libraries required for our Phi-3 vision model. So if you see, these are the libraries required to install for the Phi-3 vision model. So you can check the required libraries for this Phi-3 vision model from this Hugging Face page. You can see the different libraries that are required to install. They have listed down over here. We are not using flash attention. We are only utilizing these libraries. As flash attention cannot be run on every GPU, this mostly run with the Ampere based GPUs. So that's why we will not be installing that. So there is an error. So somehow I have pasted comma over here. So let's just remove it and let's again run this cell. Uh, we need to install all these libraries that are required to install for this Phi-3 vision model. Apart from that, we also need to install this accelerate libraries. Accelerate library is required whenever we are using this CUDA, or basically whenever we are basically utilizing this GPU server. And also if we are doing some CPU offload or something, then also we need to install accelerate. So as we are using this CPU server, we also need to install this accelerate library. Apart from that, once this installation is being done, we will be further going with the next part of the code. So in the next part of our code, we will be importing this Phi-3 vision model. This Phi-3 vision model comes with 128K basically context length, and we can have different use cases which we can do using this Phi-3 vision model. They have listed down over here. So we will be basically using this OCR module, OCR basically use case for from this Phi-3 vision model for our purpose. So let's first import that Phi-3 vision model from this transformer. So for that part, let's first create a folder where we are going to save our Phi-3 vision model. So I am creating this Phi-3 vision folder. Let's also import the warnings to ignore any warnings, such that we do not see a lot of print statements in our cell output. Now we can import this Phi-3 vision model from auto model for causal LM, and we can utilize this from pretend function from this, and we can pass different arguments to it. So if you see, I have passed the folder path where I need to save this Phi-3 vision model. I have passed this CUDA as device map to run this model on GPU. Apart from that, if you see, I have also passed this attention implementation as eager to make sure that it doesn't use flash attention, as our GPU server won't be able to run the flash attention part. So apart from that, if you see, we will also need to take care of the processor. We also need to import this processor. Processor is basically will be used to process the input, such that it is having a llama tokenizer to tokenize the text content, and it will be having this Phi-3 vision image processor that will be used to tokenize the image part. So these two things that we are going to import from this transformer, and meanwhile it is getting downloaded, we also need to get our Google API key. For that part, you can go to Google AI Studio, and in its section here you can click on this get API key, and you will be given an option to create your own API key. You can check like how many calls or requests you can make per minute for this Google API key. They have listed down here. So if you see, you can do 15 RPM per minute, basically requests per minute, and around 1 million tokens per minute can be generated. And per day, we can do around 1500 requests per day. And this particular section is free of charge. And so we will be only utilizing this API part. And if you go above that, there are some charges. So you can create your API key, and then we can save that API key in our this Google Colab directly. You can click on this key button, secrets button, and you can create a new secret, and you can save your Google API key directly over here. So once we have done that, we will be able to access Google API key and Google Gemini models. So now we have imported this Phi-3 vision model. It is basically loaded in our current Colab notebook. Next, let's import the input that we are going to pass to this Phi-3 vision model to extract the OCR from it. So we will be utilizing this particular resume or CV, and we need to. This is basically an image. If you see, this is a PNG format image. We need to extract the data from this image. So for that part, we will be using Phi-3 vision model. So as Phi-3 vision model is a multi-model, it takes both text and the image as an input. So we will be passing a prompt to it. So prompt, if you see, it is like extract name, email, phone number, and skills from the CV, and only include asked data, nothing else. And we have also at like provide your output in YAML format. So we will pass this prompt along with the image that we have this image that we have imported over here. So both of these image and this prompt will be first converted to tokens using this processor. It will use Llama tokenizer and Phi-3 image processor to convert these inputs to tokens. So let's run this cell, and we will be having our input. And you can see I have passed like max new tokens around 200. You can pass more than this or less than this as per your requirement. So once we have done that, let's generate the output and decode that output over here. So this might take a little bit of time. So like 15, 20 or 50 seconds. So let's see how much time it takes, and it will give us the output in YML format. And then we will be utilizing this output from the Phi-3 vision model as a text data that will be taken as an input to our next part, which is LaVague's AI web agent. So you can see it has extracted clearly this these information that we have required, like name equals to Justin Debowski, email, phone number, and different skills. It has also, along with these, it has also extracted education, certification, and all. Now we have text data that we have extracted from this resume or CV. We can pass this text data to our LaVague AI web agent. Before that, we need to import the LaVague AI web agent. So for that part, we will be first importing different libraries. So first three libraries are basically Gemini based libraries. These are for the Gemini embedding, Gemini LLM, and Gemini multimodal. The second, these two are like word model and action engine, as we have discussed earlier. So these will be required in our creating this AI web agent. Then we have imported this web agent and context. These are required to create this web agent. And then this Selenium driver, this we have also discussed. This will be utilized to run our code, to run it on our web page, to basically complete the different parts in our task that we have assigned to this AI web agent, like entering the different data into the job application web page and like clicking on the submit button. Now we have imported our libraries. Let's run this cell. Next, we will be basically importing the Gemini models. So this Gemini LLM, we will be using Gemini 1.5 Flash, Gemini Pro Vision, and Gemini text embeddings. Along with these, we will be passing this API key, as we have already stored in our this secrets over here in this collab. We can run this cell, and we will be having our LLM and multimodals and embeddings from this Gemini. Okay, so it shows like secret name does not exist. So now the error is like we have passed this secret name. Instead of it, we need to pass this Google API key. I have just copy pasted this one. I need to pass this name over here. So instead of this secret name, I need to pass like the name which I have assigned for this API key. So I will be writing down this, and then again run this cell. Now we will be having our language model, multimodal, and embedding from this Gemini. We need to create a context for this web agent, as this context would be required to customize this AI web agent. If we are not passing this context to our word model and this action engine, it would basically take the default models for this. So default models are OpenAI models, so that we won't be requiring over here. So for that part, we need to create this context object. So once we have created this context object, we can pass this context object to our word model and action engine. So you can see we pass this context, and it will create our word model. Apart from that, we have also created an object for the Selenium driver, and again we have also passed context to this action engine also. So once we have done these three, we can pass these word model and action engine to our agent, and it will create us our agent. Now we will be having our agent. This agent will be included of both part, word model and action engine. Word model will basically see the current state of the web page and also the input objective that we are passing to this word model. It will take both, and it will create or generate some instructions that will be passed to this action engine. Once this instruction are being passed to this action engine, it will generate some code, and that code will be taken care by Selenium driver, and it will be run through this our Java application web page. So similarly, this will go into a loop until this AI web agent finds out like we can stop at this point. At this point. So now we can run this. So apart from that, this is the form, as we have already seen. This is the form link that we are going to submit or basically fill out the information. So our objective is to fill out this form and submit it. I have passed this objective directly to this AI web agent, and then we can run this agent directly. So I have passed objective, user data, and display equals to true. So we can see the display in this notebook directly. So like how it is filling out in this particular, you can say this job application web page. Apart from that, I have passed this user data response. So this is basically the text data that has been extracted through the Phi-3 Vision OCR from our resume. And objective is same like this: fill out this form and submit it. So this will take a little while, and we will see our output over here in this notebook directly. So now you can see first thing that it has done is it has taken the screenshot of the current web page and then passed that objective and the this current screenshot of the current web page to our word model, and then it has created instruction like fill out the form with the information provided in the current state and submit it. This instruction would be passed to this navigation engine. Now you can see it has shown as the Java application web page from the UI directly, and this agent will try to fill out this application form directly by using this user data. You can see that it has now filled out the first element in this job application form, full name. It has automatically filled out this full name. And now it has filled out the second field, that is email address, as like justindeb@email.com. This is also extracted from our resume and now filled out in this email address field automatically using this AI web agent. Similarly, it has also filled out this phone number exactly the same as it was written in our resume. Now you can see it has also filled out the last part as an skill, and it has completely filled out all the different skills that are being written in the resume, all the likes from Python to AWS. It has filled out all the different skills over here. So you can see now that all the required four fields, full name, email address, phone number, and skills, are being filled out by this AI web agent directly. So now you can see it has filled out all the information in this job application web page and clicked on the submit button and submitted the information to this job application form. So great, we have created one of the application through this AI web agent. You can utilize and a different use case and implement your own use case, like booking a ticket in any website, booking a flight ticket or something, then reading out some website and finding out particular information in that website, like searching for medical data or medical information through a website which you might be thinking is basically a reasonable and responsible site. So in that way we can basically implement this AI web agent. We can use it for different purposes. I have showcased you one particular use case. you can use that and implement it for the different purpose also. So yeah, thanks for making till the end of this video. Goodbye until next time.